Greetings and welcome to the Dr. J Vlog series. It's Monday, March 31st, 2025, and on Mondays we look at mathematics and statistics. But today we're going to apply that knowledge to the study of climate change, and especially global temperature changes. Okay? So you've heard me say this before. Science always has two main jobs to do: description or discovery, and explanation. So in the case of climate change, we can talk about what's happening both in terms of temperature variability as well as changes in weather patterns. For today's vlog, I'm just going to be focusing on temperature variability over time. There are two crucial issues we have to consider. First, we have to accurately describe the patterns and the nature of these temperature fluctuations over time. And then second, what explains the pattern? In other words, what are the key determinants of global temperature changes? So, first, what do we know then about temperature changes over time? Estimating global average surface air temperature increase, for example, requires careful analysis of millions of different measurements from around the world and multiple sources, including land stations, from ships and satellites. So despite the many complications of synthesizing such vast amounts of data, we're pretty confident, and scientists around the world have concluded independently and unanimously that global average surface air temperatures have increased by about 1 degrees centigrade or Celsius, or about 1.8 degrees Fahrenheit since 1900. And while the record does show pauses and accelerations, we see that each of the last 4 decades in particular has been warmer than any previously recorded. And so here's a chart. That's the best way to show this. Here's a chart. Apologize if you're looking at this on a phone, it's going to be quite small, but this chart shows the global land and ocean temperature anomalies measured over time, dating back to 1850. It actually goes from 1850 to 2023. Okay? So what that means is we're looking at the global land and ocean temperature anomalies that represent the difference between the observed temperatures and a longer-term average. Now, that longer-term average can be configured differently. So this one looks at specifically compared to 30-year averages. And so what we're doing there is estimating the likelihood or the degree to which the observed temperatures vary from the expected 30-year averages. All right. So anything below that line, which is 0 degrees Celsius that you see kind of in the bottom third there, anything below the line represents an observed set of data that's below the expected average, and anything above is, again, shows a global increase in temperatures, or the expected, compared to what's to be expected. So you'll see that in the first half of the chart there, basically everything up to about close to 1940 is below expected on average compared to the 30-year trends. And then in the latter half, and certainly since the 1980s, we see that everything is above the expected averages. Okay? And indeed, what we see then is that 2023, which is where this particular chart ends, set the new record. So, and in fact, all of the last 10 years have been amongst the 10 or the top 10. It varies year by year, but all of the last 10 years have been the warmest on record. And then we had 2024, which I haven't shown you on the chart. So the Earth's surface temperature in 2024 was, again, the warmest on record. Several independent sources have reached the same conclusion, and overall the Earth was about 2.6 degrees Fahrenheit, or about almost 1.5 degrees Celsius, warmer in 2024 than in the last half of the 19th century, that 1850 to 1900 sort of pre-industrial period. And again, all of the last 10 years have been amongst the warmest on record. And also, 2023-24 saw this record streak of 15 consecutive months of record-setting temperatures, which is an unprecedented hot streak, we would say in sports, but in this case, I'd say it's an unprecedented heat streak. And there are a variety of other indicators that have confirmed the recent warming trends as well. So you can look at everything from the melting of the polar ice caps to rising ocean temperatures, and so on. And finally, we should note then, too, that the warming and precipitation changes are altering the geographical ranges of many plant and animal species, including humans, arguably, as well as the timing of their life cycles. So for humans, we know that in many places the temperatures are just what we typically or conventionally will call unseasonably warm, right? Like hitting 97 degrees Fahrenheit in March 25th in Phoenix, Arizona. That set the record there. And most remarkably, speaking of Phoenix, in 2024, the daytime highs exceeded 100 degrees Fahrenheit from May 27th to September 16th. That's a record streak of 113 consecutive days. Of course, they like to say in Phoenix, well, it's a dry heat though, right? Meaning very little humidity. But and so it's not quite so bad. I don't know about that, because if I heat my oven to say 110 degrees, and again the temperature exceeded 110 many of those days in Phoenix, that's a dry heat too, but I'm definitely not going to sit in my oven to test that idea or just how uncomfortable it might feel. So, okay, well, anyway, I'm not a global climate expert, obviously, so I'm not going to argue that I have a full or definitive answer as to what's happening. But really, the key issue here is to say, okay, well, what explains then the patterns that we're observing? So that's a complicated question, and it's a controversial question to a certain degree. All but the most anti-scientific people on the planet, though, agree that global temperatures are in fact warming, and that the process extends to basically all regions of the world. But it's the why question that gets at least some people a bit more agitated. Okay? So let's look then at the statistical evidence and use our understanding of mathematics and statistics to argue for the most likely of the causal factors. Okay, so let's start with our basic climatological concepts and arguments. And the main one has to do with greenhouse gases and how these affect the Earth's balance and climate in general. Right, so the sun is, of course, our primary source of the Earth's energy, and it is the source of the Earth's energy ultimately, and the Earth's climate. And so some of the incoming sunlight is reflected directly back into space, right? Especially if it hits bright surfaces like ice and clouds. The rest, though, tends to be absorbed by the surface in the atmosphere. And much of the absorbed solar energy is re-emitted as heat. The atmosphere, in turn, absorbs and re-radiates heat, some of which, again, escapes into space. Now, any disturbance in this balance of incoming and outgoing energy affects the climate. So this is the key kind of mechanism overall, and everybody agrees on that point. So, for example, even a small change in the output of the sun's energy will affect the balance directly. In that sense, we should always consider the sun's activities, no matter what else might be happening or what else people might be doing with their activities. In addition, then, we have to consider then the greenhouse gases in the atmosphere, water vapor, carbon dioxide, methane, and nitrous oxide. So greenhouse gases warm the surface of the Earth because they absorb and emit heat energy in all directions, including downwards. All of this then keeps the Earth's surface and the lower atmosphere quite warm. Without the greenhouse effect, life as we know it, of course, wouldn't have evolved on our planet. So to some extent, of course, this is a good thing. We need this. The problem is that if you start to add too much in terms of greenhouse gases to the atmosphere, this makes it more difficult then for heat to escape into space. And if the energy leaving is less than the energy entering, the Earth warms and a new balance will be established. again, the Earth will survive, the Earth will continue to function regardless of how warm or how cool it is. We've seen, of course, historically, ice ages, these glacial periods, and also periods of considerable warmth. So that's going to happen inevitably, no matter whether humans are here or not. Now, the issue that most people are a little bit more animated about then has to do with what are the relative effects then of human activities in this regard. Because scientists are quite well aware, I mean, we're all in agreement that there's a combination then of both human and natural factors that are affecting the Earth's climate balance and the overall warming. And there's also basically consensus too that the increase in CO2, carbon dioxide, and the increase in CO2 is the single biggest contributor. Right? Just go ask the folks on Venus what happened there. That's another story for another day. Anyway, so we know for certain that atmospheric concentrations of carbon dioxide and methane and nitrous oxide, all of these things, have increased significantly since the start of the Industrial Revolution. So in the case of carbon dioxide, the average concentration measured at the Hawaii Mauna Loa Observatory has risen from 316 parts per million, ppm, in 1959 to more than 427 ppm in 2024. Okay, there you go. All right. And so again, this chart basically describes that very clear upward trend as such. Okay. And since pre-industrial times then, the atmospheric concentration of carbon dioxide has increased by over 40%. Methane has increased by 150%, and nitrous oxide by roughly 20%. And more than half of the increase in carbon dioxide has occurred since 1970. And increases in all three of these gases have contributed to the warming of the Earth. But again, the argument suggests that almost all scientists agree that the increase in CO2 plays the largest role in this regard. And so, again, scientists have been studying these things and looking deep into the past for that matter. They can look into the analysis of the air that's trapped inside the ice that's been accumulating over time in the Antarctica, for example. And this shows, again, CO2 concentrations and how they started to increase significantly in the 19th century. And by the way, they had stayed at a fairly steady state by our best estimates, again, through the scientific analyses, usually in the range of 260 to 280 ppm for most of the previous 10,000 years. So ice core readings extending back 800,000 years shows that during that time, CO2 ranges generally fluctuated or held within the range of 170 to 300 ppm. Okay? So the fact that we're now well over 400 is very clearly an anomaly, and it's a concern. Okay? All right, so let me talk about this again in terms of the complexity of the processes that are involved here. So based on the physics, in terms of the amount of energy that CO2 absorbs and emits, a doubling of the CO2 concentration from pre-industrial levels up to about 560 ppm, which we're not at yet, by the way, would by itself cause average global temperatures to increase by about 1 degree Celsius. In the overall climate system, however, things are more complex. In particular, warming leads to further effects or feedbacks that either amplify or diminish the initial warming. And so again, that's where the science is, it's excellent, but it's where the debates really start to crop up. So we then have to analyze these feedback mechanisms, for example. So one of them would be the feedbacks involved in various forms of water. A warmer atmosphere generally contains more water vapor. Water vapor is also a potent greenhouse gas and causes more warming. Its short lifetime, though, in the atmosphere keeps its increase largely in step with warming. And so water vapor is treated as kind of an amplifier, not necessarily a driver of climate change. Higher temperatures, though, also, especially in the polar regions, will melt the sea ice and reduce seasonal snow cover, exposing a darker ocean and land surface that can absorb more heat, causing further warming. Another important but uncertain feedback mechanisms concern changes in the clouds. Warming and increases in water vapor together may cause cloud covers to increase or decrease, which can either amplify or reduce temperature changes, depending on the changes in the horizontal extent, the altitudes, and just the different properties of different types of clouds. And then you've got the ocean, right? These enormous oceans moderate climate change because the oceans are this remarkable and huge heat reservoir. So, and it's hard then to heat its full depth because the ocean waters, of course, are so deep in many places, but the heat, of course, tends to rise and stay near the surface. And so the rate at which heat is transferred then to the deeper parts of the ocean is actually quite slow. Observations, though, of the subsurface ocean temperatures are limited to really only dating back to about 1970. But since then, what we've observed is that the warming of the upper 700 meters of the ocean is quite apparent and quite significant. And even deeper warming has started to occur as well since about 1990. Surface temperatures and rainfall in most regions vary greatly from the global average because of geographical variations, the different locations, and the particular latitudes and their continental positions, and so on. So, what I'm suggesting then is that estimating the effects of the different feedback processes and the pace of warming and even regional climate change requires the use of enormously complex computer-generated mathematical models looking at atmospheric and ocean, land, and ice conditions that are built upon or dependent upon, right, the basic established laws of physics and our latest understandings of physical, chemical, and biological processes that are affecting climate. So these computer models then vary considerably in terms of their projections of how much additional warming we should expect, but all such models agree that the overall net effect of the feedbacks has been to amplify the warming. And of course, then there are still other natural causes that affect the Earth's climate, such as volcanic eruptions. These eruptions increase the amount of small or aerosol particles trapped in the stratosphere that reflect or absorb sunlight for 2 to 3 years, depending on the size of the eruptions. And as mentioned, an increase in the sun's energy, or the output, I should say, will lead to a very different pattern of temperature change compared to that induced, for example, just by CO2 concentrations alone. So these are factors that extend beyond, human activities as such. And this is where we get to the nub of the issue then. So rigorous analysis of the data and evidence show consistently that most of the global warming over the past half century, roughly 5 decades, cannot be explained by natural causes alone. Again, to be clear, scientists routinely test whether purely natural changes in the sun, volcanic activities, and internal climate variability could plausibly explain the patterns of change observed in the many different aspects of climate system, and specifically in terms of temperature. And these analyses always show that the observed climate changes of the past several decades cannot be explained solely by natural factors. So then the question becomes, okay, well, can we discern the relative impact or influence of human activities? So that's where the real debate lies, both scientifically and because of the political implications. So to answer that question requires that scientists consider many of the natural variations that affect temperatures and precipitation and other aspects of climate from the local to the global scales, and on time scales from days to decades or even longer. And there are three main points then that I want to make in this regard, based on the current state of climatology and the full scope of scientific knowledge, evidence, and modeling. First, there's widespread, if not universal, consensus then that human beings and their activities are definitely and unequivocally contributing to climate change and the warmer temperatures that we're seeing. Okay? You have to start there. You have to agree with that, or you've already lost. But second, the relative impact of how much change can be attributed to human activities remains more uncertain. No one has a definitive answer. Most of the estimates that I've seen range from 70 to perhaps as much as 95% of the change being attributed to humans. Now, the Intergovernmental Panel on Climate Change, the IPCC, arguably the leading national or international body for assessing and evaluating climate change and the different models and the evidence, the IPCC has concluded that human activities, particularly the release of greenhouse gases like CO2, are the dominant cause of the observed warming trends that we've seen, at least since the mid-20th century. And if you're interested, the IPCC has published several comprehensive studies, meta-analyses, looking at the full range of climate science since 1990, and they all tell the same story. The latest studies reveal that almost 100% of scientists now agree that humans are having a measurable impact on climate change. And folks, rarely do we see this level of scientific consensus on anything. So please don't listen to that tiny minority of random voices or whoever who deny all of these reams and reams of evidence. There's no question that human activities such as burning fossil fuels and deforestation and industrial processes have led to significant increases in greenhouse gas concentrations in the atmosphere, and that we're trapping more heat and causing the planet to warm. All right. And then third, there's one more uncertainty. How much warming will we see? And I guess for our purposes, since most of you are probably younger than me, but regardless, how much warming will we see in the 21st century? That's hard to say for some very good reasons. First, we cannot predict how much CO2 human activities will emit. All of that depends on factors like how the global economy develops in the next years, looking at society's energy production and consumption patterns and the main sources. Second, with our current understanding of the complexities of how climate feedbacks operate, there's a range of possible outcomes, even for a particular scenario of carbon dioxide emissions. So we have to couch these estimates in terms of probabilities. Again, good to know statistics in this regard. And then third, on timescales of a decade or so, there's natural variability too that's going to modulate the effects of the underlying trends on temperature. So this last decade then has been particularly harsh. And our best guesses, our best estimates suggest that the trends should continue. But again, there are a number of other possible intervening factors that we cannot necessarily predict that could help avert the most disastrous of consequences. I don't know about you, but I'm not really comfortable, though, with that level of uncertainty. But that's what we have to deal with. We know that the Earth will continue to warm, okay, no matter what. All of the projections, I don't care who you are, who's doing the modeling, suggest that the Earth is going to continue to warm based on both the natural factors at play and the state of where we are, with 8 billion people and industrializing China and India, among others, and all of the rest of the world that has continued to change its production and energy consumption patterns. So all of that's going to continue. I have something to say about that in a moment, but okay. So, and our best estimates, if there are no changes in terms of the ongoing developments that we're seeing, and if there's no new technologies or fundamental policy changes at kind of societal or global levels, like if we just continue without doing anything further, for example, okay, the best estimates based on the concurrence of the scientific knowledge and putting these into the different kinds of models with different sets of assumptions suggest that we should expect a further global warming over the course of the next century, projected to be about 2.5 to 4.5 degrees Celsius, or 4.5 to 8 degrees, roughly, or just over Fahrenheit. So, again, if nothing changes, we're almost certain that we're going to, by the end of this century, see a much warmer planet than even what we see right now. So the Earth, as I say, is going to continue to warm. There's no question about that, okay? But what I want to end today with is to suggest that we do have some degree of agency in the matter. And while we tend not to act on most things until it's too late or to the right up against it, the 11th hour, right? We don't write those term papers until the last possible night or the last possible minute in some cases. Or we don't start saving money in a serious way until we're in our 50s or 60s when we should have started in our 20s. Anyway, you know what I'm talking about. But let me end on a note of optimism. So humans are incredibly innovative and resilient. And there are truly opportunities now to pursue renewable energy sources and lifestyles that can markedly reduce our carbon footprints. And increasingly, people are starting to do that. Okay? And perhaps most optimistically, I'm 100% convinced, and I'm not 100% convinced of much, but I'm 100% convinced of this, that just as we've seen the computer and the digital and the internet revolutions transform our lives in the last few decades, and AI increasingly now in the coming decades, I'm 100% convinced that we're going to see innovators and entrepreneurs in the next decade or 2 decades at most who are going to build upon the existing science or the emerging science and technologies to arrive at profitable and efficient renewable energy production methods. And we're almost certainly going to also discover some mechanisms to reduce, if not reverse, the effects of carbon emissions and carbon capture in the atmosphere, among other things. So I am quite optimistic about what humans can do on the technological side of things. And I'm even cautiously optimistic at the cultural level. What do I mean by that? So, well, finally, communities and tribes tend to be quite remarkable in rallying around common threats, or responding to common threats. And we still see that today. And this has been the pattern throughout human history. So to achieve the next step in averting potential long-term catastrophe, or at least human-driven global climate warming, will require the equivalence of human societies everywhere banding together to fight off the threat of some extraterrestrial invader. Right? I'm just speaking metaphorically here, right? In other words, if there were these evil alien beings that were attacking the Earth, right, or like the old movies like Mars Attacks and so on, then I'd bet on human beings everywhere rallying together to the cause. Now, I know that rallying together and consensus building doesn't look very promising in the current kind of geopolitical climate in which we're living. There's been strident, nationalism and competition for what's left of the Earth's scarce resources. But that said, there's certainly an international team of experts, of scientists, and a huge international community of thoughtful people from all walks of life and all parts of the planet who understand quite well exactly what we're facing. And if you've listened to the blog this far, you're one of them, almost certainly. And there are enlightened politicians, yes, believe it or not, from all walks of life who know all of this as well. They're just not, for the most part, in power or in the highest echelons as such. And if, and part of the challenge too there is that there's just this, and you've heard me talk about this fire hose of misinformation and disinformation that's being propagated by bad actors. So that's going to make all of this a bit more of a challenge. Now, but having said that, and I'm just speaking for myself now, obviously, I truly believe that we have to just keep trying, right? I'll do what I can in my life, whatever remaining years I have, to share the best information and knowledge and wisdom and work towards building a broader base and a common understanding. That's why I don't do shows or vlogs specifically on politics and division. I do them to try to explain human behavior. But the last thing I want to do is try to alienate people or say, oh, you're smart or you're dumb or any of those kinds of characteristics. I'm trying to understand the human condition and the natural world and music and all of these things. And my efforts are always aimed at trying to bring people to common understandings. Okay? That's my end game, so to speak. All right? And so it's not just the scientists then that are interested in, trying to solve these problems. I think there's this growing population internationally of concerned scientists, politicians, religious leaders, and average people like you and me who are starting to think more seriously and take these issues more seriously. And it's not about the politics of a right wing or left wing of these. It's about trying to understand the human condition and, again, if you will, even the common threats, the common issues that we're all going to have to contend with eventually. Okay, so, and again, my view is that the more people working on these issues and doing vlogs, not just the science, the better, right? So all of us then can help in our own ways. And then we can improve our knowledge, correct the mistakes, including mistakes, for example, I might have made in today's vlog, and just keep striving, okay? Let me use an analogy from sports again. At my best, I can make about 80% of my free throws. If I'm practiced, if I'm in shape, and I'm, I can I'm no Steph Curry. He can probably make like outside of games like 95 to 100%. So I can make about 80% of my free throws, all right? But of course, that means I'm still missing 20% of the time. And so when I'm missing free throws, or when I'm wrong, you can pick up the slack. Any of us can pick up the slack, right? Or you can sub into the game for me because I'm limping or I'm hurting or I'm not at my best. Or give me some time off, a couple of games to get better. You know what I'm saying? Or maybe you're the next star on the team and you just need your moment out on the floor in the sun to shine, right? Maybe you're ready to take over the team. So honestly, I'm cool with all of that, right? What I'm suggesting is at the end of the day, I truly believe we're all on the same team. Again, however naively optimistic I might be about that. And I'm just betting that we're all hoping to win in the end too, right? And so let's just keep going and keep trying. All right, until next time, as ever, may you and yours continue to create peace in your lives and nurture love in your hearts and hug someone in need. Oh, and let's create the best team that we can with the best strategies over time, over the next several years, to create a more sustainable and livable world. It's in everybody's interest. We all want to win that game, don't we? I hope so. We'll see you soon.